Okay, so we got a mouthful today. It's the corresponding parts of congruent triangles are congruent. It's something that we can say once we know triangles are congruent. So it's all about corresponding parts. Okay? And we know what those are. Like side goes with side, angles go with angles, and so forth. But the new reason we have here is CPCTC, which says corresponding parts, so those matchings that we've been doing of congruent triangles are congruent. So when we look at a picture right here, I know those triangles are congruent. For example, ABC is congruent to ADE because we know that that would be a side angle side scenario. Okay? And by CPCTC just means that because we know the triangles are congruent, we know that these match up. We know that these match up. And we know that these match up, right? Because congruent triangles have everything matching. So once you show you have triangles congruent, you can say any side that you want, as long as it corresponds, is congruent. So like C and E, for example, would be a fair thing to say because we already know the triangles are congruent, so we can state any of its corresponding parts to be congruent as well. So let's take a look at that in the form of a proof, which is most of what this section is. We are given R and X, S and Y, and that's really great. We also have the side. So this is going to be a, we already know that these triangles are congruent. They're congruent because remember we got SSS, SAS, AAS, and ASA, and HL. Those are angles side angle, right? So it'd be safe to say that triangle ABC, triangle RST is congruent to triangle, let's see, RST XYZ. Okay. But what we're trying to show is that angle T is congruent to angle Z. And the reason why is because we already showed the triangles were congruent. So of course, T and Z are going to match up as well because we already knew the triangles were congruent. That's called corresponding parts of congruent triangles are congruent. Let's see that again. So we got AB and DE. We have BC and EF. And we also have the fact that these are right angles. Okay. So first, my thought would be HL. Remember, HL says you need three things. Two right angles, which we have. Two congruent hypotenuses, which we don't have. Or I'll just say congruent hypotenuses and one congruent leg. We actually have both legs congruent, but we don't have this. So we can't really use HL since these hypotenuses were not given as congruent. Now, I suppose you could, but you'd have to use the Pythagorean theorem as one of your reasons, which we haven't used yet. One way we can get around this, though, is couldn't we just say that B and F are congruent because all right angles are congruent? And then we not only have that as a right angle, we have that as an angle measurement like that. And then for me, I would see SAS. And the triangles that match up are the two triangles, which would be ABC and DEF. So yeah, AC and DF are congruent because I know the triangles are congruent, so all of its parts must match up. So this is just a corresponding parts congruent triangles are congruent. So we actually did get this at the end, but we couldn't use it in the middle, right? Because we found out at the end that the hypotenuses were congruent, but we couldn't use HL here in the middle, so we had to use something else. Okay, so outside of the scope, so that's what it looks like as a proof, but let's just look at maybe one that isn't a proof to give it some contrast. Name a theorem you can show to show the triangles are congruent. I mean, they have a shared side. So wouldn't that mean that they are congruent by SSS? That's the reflexive property. The shared side idea. And then it wants you to explain, well, why should these angles be congruent then? Well, it's because you already did the work. You already found out that the triangles were congruent. So corresponding parts, like those two angles, of congruent triangles are congruent. So again, that's going to look like corresponding parts. So whether you pick two angles, whether you pick two sides, we already have all the sides, but in a different one. So corresponding parts of congruent triangles are congruent. That's all it says. And it's just this extra reason we can throw on at the end to get what we want, to get the sides to match up or the angles to match up that we want. And it requires that we have congruent triangles before we can do that. So let's look at two more proofs and then that'll be it. So we got our given. We aren't given that much, but we are given we have parallel lines. And those lines are congruent. So we draw a little dash. Okay. Alternate interior angles. This isn't the first time we've seen this picture, right? We got parallel lines, and then we have a transversal here, which, remember, we make that Z shape, like this. These are the interior angles here, which corresponds with K and Q. And for the same reasoning, if I were to draw JP, which goes like this, we could still make that same. So the triangles are kind of existing like in this space. Like kind of like here, something like that. These angles, which are still in the Z, if you draw the Z like this, basically these match up as well. And this is a little hard to see, but we've seen it before. J and P are going to match up too. And that's what's a little tricky about this one, is there's two statements in one. But anyhow, after having all of that, we have all this goodness right here, which you can see is an angle and then a side and then an angle. So the two triangles are congruent, which is normally the end goal, and then we're done. But this section says, no, let's go a step farther. Let's talk about some of the parts that are congruent as a result. That's CPCTC. So what does it want? It wants it to find a midpoint of JP. Well, wouldn't it be great if we could look here and show that JM and MP are congruent? Wouldn't that be nice if we knew that? Because then we would know that M is in the middle by the definition of the midpoint. Okay. So, but why are these two sides equal? Why should we believe that those are equal to each other? Well, the triangles are already congruent, so the sides, those are corresponding sides, they have to match as well. And that's because corresponding parts, like those two double dashes of congruent triangles, which we already know, are also congruent. So you can match up any corresponding part you want as long as you know the triangles are congruent. Okay? All right, one more. So this is going to be our given. We got a matching here, and we have this as a bisector of the angle. Okay? So that blue angle is being cut in half, here and here. So that's going to be angle BAC and DAC. And they are equal because that's what bisect means. Okay? And the whole goal is to get some parts going so we can say the triangles are congruent. And reflexive property is a great hint. There's a shared side, right? AC is congruent to AC. Okay. Let's see, what next? Do we have enough? Do we have enough to say that the left and the right triangle are congruent? And yeah, it looks like the overused theorem for today was SAS, because we do have that. Look, we got side, angle, side, side, angle, side. So that means that I'm just going to copy and paste this, right? Change these to triangles. And because I was careful in my choice of letters before, I think that would be a fair congruent statement. So sometimes you can do that if you're careful with your angles. Great. So triangles are congruent. Awesome. But why should you believe that BC and DC are the same? There's no markings. Why should they be equal? Well, the triangles are equal. So all the sides of the triangles are equal to each other. So of course, it should be equal. And the reasoning is corresponding parts of congruent triangles are congruent.